In this session, we're going to talk about law, the law of physics. A body in motion tends to stay in motion. When traveling along highways and local arterial streets, they are designed to traverse overall areas. This lesson will concentrate on what happens once you leave the arterial and enter a neighborhood, from a time and energy waste perspective. Let's look at some typical suburban street patterns. Most suburban neighborhoods, as shown here, ignore the science of flow, but to understand this, we must explain. Newton's law: a body in motion tends to stay in motion, and that body is typically a 2-ton vehicle. Since we're talking about local streets, the typical speed limit's 25 to 30 miles an hour. This speed we call residential speed. A vehicle doesn't go instantly to residential speed in normal soccer mom driving. It'll take about this amount of time, which is also about 200 feet, to reach flow, and then it takes about this amount of time and another 200 feet to come to a stop. We call this a flow cycle. The more flow cycles, the more time and energy consumed simply to get home. This was demonstrated in session 1, but let's review it again. This approved preliminary plat looks efficient to those who have not reviewed these sessions. From a flow perspective, most of the homes in the neighborhood, getting home means negotiating short street segments. These are far less than 400 feet. Stopping maybe at each intersection, and then additional delay to make a turn. Instead of residential speed, the overall average speed will be between 10 and 15 miles an hour, depending upon how aggressive the driving is. While vehicles will continue to get more energy efficient, there's no technology yet that will recover lost time. When we first designed Cove neighborhoods about a quarter century ago, to be clear, we had not recognized the critical importance of flow. This did not come into play until about 2005, 15 years ago, when we began researching how to make our own designs better. As we were redesigning this already approved plat, we're looking for a main street approach, which gives the subdivision more of a neighborhood character. It's also designed to maintain flow as much as possible. While there's no such thing as perfect design, the average time and energy per residential unit will plummet compared to the approved original plan. The street length was reduced by 33%, which in this case saved $300,000 in construction costs. Yet the density remains the same, resulting in larger lots that in this case increase lot premiums by $600,000. Less intersections means increased safety. There are 136 homes in this neighborhood. A typical single-family home will have about 10 trips a day. If each of these trips on average is reduced just 15 seconds, that's 15 hours less travel annually per home, or at flow speed, the equivalent of nearly 400 miles per year. Thus, in theory, with 136 families each year, we reduce the overall distance traveled equivalent to over 50,000 miles, or twice the circumference of this planet, just in this one small neighborhood. We require auto companies to spend billions just to find a way to get another mile per gallon out of their cars. Yet we completely ignore flow when designing development street patterns, especially suburban. Today, every consultant, developer, and municipality we teach using the Land Mentor system, and every neighborhood we design, flow becomes a critical component.